Hey YouTube, it's Brendan, Cusack Prep, coming at you with a video to help you for the SAT. In this video, we're going to be describing problems that use the word inscribed. So inscribed is a word, interesting enough. It comes from Latin. The word in comes from into, or in meaning into, and scribere, I think is how you say it. Probably totally butchered that. But that basically just means scribed, and that means to basically write inside. So anytime you see the word inscribed, it basically just means one shape is drawn within another shape. And let's go ahead and draw a few examples of some inscribed problems. Let's say we had a circle inscribed inside of a square. So this would be circle in square. Oh, well, the circle is going to be inside of the square, and it's inside of the square in such a way that it should be perfectly inscribed. So there's my circle, looks kind of like an apple, and basically my square should touch it at exactly 1 point on each side. The top's kind of goofy, but I think you get the idea. So that would be a circle inside of a square. Now these questions typically ask you to find the shaded region. So a lot of times what they'll do is they'll shade the space in between the circle and the square, something like that. And what you need to know about any of these shapes is you're looking for one key feature of one shape to be equal to one key feature of another shape. So let's talk about what I mean by that. So here, let's draw the diameter of the circle. So the diameter would go right through the circle. Notice how that's the exact same thing as the side of the square. So when the circle's inside of a square, the diameter is equal to the side of the square, or we could say D is equal to S. So a lot of times what they'll do on a test is they will simply tell you the radius. They will give you a line like this, and they'll tell you that the radius is 4. Well, if the radius of the circle is 4, what would the diameter be? Twice the radius, so the diameter would be 8. So if I'm given radius is 4, I can then deduce that my diameter is 8, which then allows me to determine that my side length of my square is also 8. Now, if I wanted to figure out the area of the shaded region, generally anytime you have a shaded region, your area is equal to the shaded region, is equal to your larger area minus your smaller area. So the larger shape in this case is the square. We know the equation sheet tells us that the area of a rectangle is length times width. The area of a square is just side times side, or side squared. So that would be 8 squared. And the area of a circle is pi times the radius squared. So this would be pi times 4 squared. So I would end up with 16. No, sorry, bad math. I would end up with 64 minus 16 pi. And that should be one of the answer choices. Let's say instead of drawing a circle in a square, we had a square inside of a circle. This case is probably a little bit harder. So what I'm going to do here is I'm going to draw a square. I'm going to try to make the circle not look too goofy this time. But if the square is inside of the circle, or inscribed inside of the circle, my circle needs to touch my square right at the corners in each case. And try to make this look as much like a circle as possible, while still touching each side. Okay, not bad. Looks a little more like an ellipse, but close enough. So when a square is inside of a circle, it's not as clear which two sides are related to each other. Like the side of the square, in this case, is not the diameter of the circle. Rather, if I draw the diameter of the circle like this, draw that a little better, like that, I can see that it's my diagonal of my square that is the same as my diameter of my circle. So fortunately, anytime you dissect a square, you form a 45, 45, 90 triangle. So this is 45 degrees. This is 45 degrees. And so if I say the sides of my square are x and x, then, let me draw that a little bit better. So if I say the sides of my square are x and x, then this is x root 2. That's another ratio that's provided in that equation sheet. So what we can see then is there's a few relations that we can make. We can say that our diagonal is equal to our diameter, and we can see that our diameter is equal to our side of our square times root 2. So for something like this, they may tell you the radius of the circle. So I'm going to draw the radius, and I'm not going to draw it in such a way that it lines up, because a lot of times they're not going to want to give you that hint. So let's say that our radius here is 5. So this is starting to get a little bit sloppy. But if our radius is 5, that would mean that our diameter is 10. So if r equals 5, d is equal to 10. And so if our diameter is 10, we can figure out the side length of the squares by saying 10 is equal to s root 2. Well, dividing both sides by the square root of 2, I get s is equal to 10 over root 2. Multiplying that by root 2 over root 2, I find s is equal to 10 root 2 over 2. The 10 over 2 reduces to 5. So this just becomes 5 times the square root of 2. And that's the side length. So if I wanted to find the area of the shaded region, in this case, the larger part is going to be your circle. And that circle has a radius of 5. So that area is going to be 25 pi. The area of the inside is going to be the side of the square squared. So that's going to be 5 root 2 squared. And so this is going to be 25 pi minus 25 times 2, or 50. And that's how you would find the area of a square inside of a circle. So I'm going to go ahead and stop this video here. That was 2 examples, a square and a circle and a square, which is probably going to be your most common inscribed question. In the next video, I'll talk about how a cube can be inscribed inside of a sphere and how a sphere can be inscribed inside of a cube. Thanks for watching.